Hi, everyone. If you haven't already introduced yourselves in the chat, please do that. If you have any actual questions for the presenters, please put that in the Q&A section. It might be difficult for us to catch in the chat during the presentation. So if you have any questions, please put it in the Q&A so we definitely see it and get it answered for you. If you have any technical issues, we totally recommend logging out and logging back in. But if there's an issue that that doesn't fix, please post it in the chat and we'll have one of our attendees from Causewave try to help you resolve that. And at the end of the webinar, there'll be a short survey to help us gauge the success of this presentation and the helpfulness. So if you wouldn't mind taking a couple minutes to fill that out, that would be fantastic. And you'll get that in an email as well as a link in the chat. So just keep an eye out for that. And so I'm going to get started and jump into our agenda first. So quick overview of the agenda. We're going to talk about the AMPED campaign, well, beneficial electrification, the technologies, what we're recommending, and we'll hear from some professionals. And then we'll get into best practices, incentives, and some of the resources that AMPED is offering. So quickly, I'll introduce myself, and then I'll pass to our other presenters to introduce themselves as well. My name is Matt Corona. I am the campaign manager for Heat Smart Monroe, and I'll talk more about Heat Smart Monroe later in our presentation, but it's our little mascot, Doug, here. I work for a local organization called the Climate Solutions Accelerator, and I'm happy to be the MC for tonight.
I'm Isaiah Grigos. I'm a senior project manager at Sustainable Comfort. Sustainable Comfort does all manner of green ratings and kind of consulting for high performance buildings. We've been a big part of helping to electrify a lot of different multifamily buildings throughout upstate New York, Massachusetts, and some of the surrounding states.
My name's Simran Sandhu, project manager with Sustainable Comfort. And as Isaiah said, Sustainable Comfort's doing lots of work with new construction and also existing buildings. The existing buildings team is the team that I'm a part of. So happy to answer any questions you guys may have at the end of the presentation. Thank you.
Thank you. And I also just want to recognize our support group, Sarah and Aaron from Causewave. So the goals of this webinar, we really want to help people. I'm not going to read this, but we really want to help everyone get familiar with the technology for building electrification, understand the differences between different options, some of the pros and cons, and take away some best practices and see what you can apply to your organization or your building. So the goals of the AMPED campaign, ultimately, we're really trying to reduce the impacts on climate change by reducing carbon pollution from fossil fuel heating systems and otherwise. So promoting building electrification, beneficial electrification. Really, we're a public resource to get information about the technology, about contractors, about things you should be considering when considering beneficial electrification for your building. So really a public resource. And so these are our funders. And this is our steering committee, made up of people from a bunch of different organizations. And so now I'll pass to Isaiah to talk about electrification technologies.
All right. Yeah, so this is going to be a very high level discussion about some of the technologies that we're seeing out there and what they are, how they're used, and kind of, you know, the pros and cons of each system. I mean, we can't get into the details of each of these systems just because we're pretty time constrained, and any of these technologies could probably be discussed for hours on end. But I'll do my best, and if you have any questions, feel free to post them in the question section. All right, next slide. All right, so how are we going to electrify our buildings? I mean, first off, you know, why do we want to do that? I mean, obviously there's environmental impacts that we're looking at. You know, we're doing this simultaneously. We're electrifying our buildings while simultaneously making the grid cleaner. One of the best ways of electrifying our buildings is to simply reduce the loads that these buildings have: heating, cooling, hot water. So you can see here, you know, we kind of highlighted the different aspects of a high performance building. You know, we can optimize the building for solar panels. We increase the insulation, we do airtight construction. You know, all these things kind of reduce the heating and cooling loads. And on top of that, you know, as we're doing that, we want kind of a balanced fresh air ventilation. You know, we're going to make these buildings airtight, but we also know that people need to breathe and they need fresh air and clean air. And so we want to control the ventilation through balanced, you know, balanced ventilation throughout. Heat pump water heating, we'll touch on that a little bit, and then efficient heating and cooling. Those are kind of the two main technologies, the two systems that we as consultants spend a lot of time going over with builders and developers. Next slide. So here are some air source heat pump types. This is for heating and cooling. These are some kind of generic terms you might see. We'll get a little bit into the different systems in a few minutes, but just to kind of demystify some of the terminology, ductless mini split heat pumps. These are what you might see, you know, a lot of like small apartments might have them, or single family homes might have them. And basically these are usually like wall cassettes or ceiling cassettes where you have one outdoor condenser and then one or more indoor units that kind of sit on the wall or sit on the floor. Very efficient, you know, fairly simple install. You know, each unit usually has its own thermostat, and you know, we might see these like for an addition, like you're adding on to a building, just because it's fairly easy just to run a refrigerant line inside and kind of connect the two pieces of equipment rather than expanding on the existing infrastructure there. The next one down is ducted. We see a lot of these systems for a couple reasons. Basically, people like the aesthetics of a ducted system better, and they also kind of deal with small rooms better. When you have kind of a split system heat pump, you try not to oversize the equipment. And basically a ducted system allows for you to kind of adequately size for multiple rooms. So it kind of reduces the risk of oversizing equipment. Short run ducted is kind of a variation of that. And basically usually you have like less than 10 feet of ductwork, and you can serve a couple different rooms just by kind of cleverly placing your indoor unit. Split systems, touched on that a little bit already, but basically that's your standard outdoor indoor unit connected by refrigerant lines. Package systems, we're starting to see some good ones. In the past, we've seen kind of an all-in-one system that you create a, you know, like a 3x5 hole in the wall, or and you stick this system in, and it kind of can provide heating and cooling out of a vent there. In the past, they've typically been fairly inefficient, not well made, and they kind of create a fairly big thermal bridge on the wall. So they haven't been great, but we're seeing a lot of good technology kind of replacing this. Multi-zone, this could be a multi-split or a VRF system, which we'll touch on a little bit more in a second. basically you might have one outdoor condenser and that serves multiple indoor condensers or multiple indoor units that heat and cool different spaces. Versus below that, we've got the single zone, which is kind of a direct mini split system where you have one outdoor unit, one indoor unit. Typically, those are the most efficient, but you got to be aware of how you're moving heat around and conditioning all the spaces in an apartment. Next slide. All right, so these are the kind of the major systems that we see broken out. So we got split system heat pumps, VRF systems or variable refrigerant flow, and the package heat pump systems. Split system heat pumps, kind of like what I mentioned before, you have a single outdoor condenser unit and that will serve indoor heads. These are popular when you want to be able to put the heating and cooling costs on your tenants. Usually they're very efficient when sized properly. One of the big things with these systems is ensuring they're not oversized, otherwise there can be issues with inefficiencies. They newer technologies, they operate down to very cold temperatures, negative 5 degrees, negative 10 degrees. They use them in Canada. They do very well in Vermont, in Maine. So, a lot of the previous concerns about heat pump technology are kind of being mitigated by better technology. One of the concerns is where you're locating the outdoor condenser units. You got to make sure that you have space for them. They're not going to be an eyesore. They can take up roof space on multifamily buildings that you might want for solar. Yeah, that's pretty much that standard split system heat pump technology. Moving down, VRF systems. These are usually very, very efficient systems, but they're a central system. So you might only have 2 outdoor condensers that will serve a whole building. So you can, serve 30, 40 apartments off of, a pair of outdoor condenser units. And what it does is basically you have refrigerant lines that go from unit to unit to unit, kind of be some branch controllers that send refrigerant where it needs to go. But basically, these outdoor condensers just move heat from the outside through refrigerant to various indoor units. And you can kind of use whatever indoor units you want, whether wall-mounted systems, ceiling-mounted, or ducted. These are very efficient, but for multifamily buildings, you can't put the heating and cooling onto tenants, so it becomes kind of an owner-paid utility for the building. Another nice thing about these is they reduce the amount of outdoor condenser units, so you're allowing for a lot more roof space for PV, as well as a lot fewer penetrations through your roof. I mean, you can imagine if you have a 60-unit building and you have 60 condenser units on top, one for each apartment, that's 120 penetrations through your roof. And each of those penetrations cost money to install and they can all leak. So VRF systems, can be very popular just for those reasons alone. They're also great because they can be a little bit more efficient than your standard split system heat pump because they can have heat recovery, where basically a part of the building is in cooling and all other part is in heating. You move heat between apartments rather than trying to take it from the outside, which can increase the efficiency by like 10 to 15%. And last, we have the package heat pump system. These, like I said, we're seeing some more efficient units that are popping up, like the Efoca HPAC unit. But overall, we're kind of seeing the traditional ones be used less and less, but they can be a very cost-effective way where you don't have to run refrigerant lines. It's a packaged unit. You don't have to have somebody installing refrigerant lines, which may have a tendency to leak. So there are some benefits there, and I think we're seeing some better technology come out that are replacing some of the older, less efficient, leakier systems. Next slide. as I mentioned, heat pump technology has kind of come a long way in cold climates. We're seeing them be, operate very effectively and very efficiently in cold climates. So a lot of the old assumptions about heat pumps not being able to operate, in low temperatures is not true anymore. A lot of time, I mean, obviously they might need some help here and there. You might have to have like an electric resistance backup heat, but usually that's for a very small percentage of the time. You need to be aware that it will become more inefficient at colder temperatures. You might lose capacity where, it might be a 1-ton system, at 40 degrees. You might lose half that capacity at 5 degrees. So one of the ways to mitigate that is make sure you're buying the right heat pump. So there's the NEAP cold climate air source heat pump specs. They have a list online that you can kind of scroll through and find one that suits your needs by all the different manufacturers. The things we look for: variable speed compressors, really high heating season performance factors. And then obviously they do cooling as well. So you want to make sure the unit you have operates well for cooling. Next slide. One of the other technologies that we get asked a lot about is ground source heat pumps. These can be very efficient systems, but they have a high upfront cost because every system is pretty much custom. There's a lot of unknowns such as, groundwater levels and what kind of soils you have. So very efficient. They can be more efficient than your typical air source heat pump, but a lot of upfront costs. And then on top of that, if poor designs can sometimes lead to them being not as efficient as air source heat pumps. It's not free heat. There is a lot of pumping power involved, and basically, you need to make sure your system is well designed, and you need to make sure you have land for it. Basically, you have all these outdoor wells that you're pumping kind of a glycol mix through, and it takes a lot of power to pump that glycol mix through to kind of steal heat from the ground. So make sure if you're evaluating ground source heat pumps, you consider the upfront cost, a good design, and the fact that you're going to need various wells kind of dug throughout the property. Next slide. I'll kind of gloss over this real quick, but there's various types of ground source heat pumps. Vertical is what we usually see where land is tight. These can be placed underneath a parking lot. Basically, you're digging, hundreds of feet under the ground where you're going to run these pipes with the glycol loops in them. If you've got more land, you can do a horizontal system where you're running these coils, kind of spread out, like maybe under a field or a solar array, something like that. And then there's systems like the pond lake systems where you're taking from, a pond or a lake. We don't see those a lot. Don't really recommend them. And then the last two are just kind of definitions. A closed loop system is where you aren't introducing kind of groundwater into it. You're just pumping glycol through a closed loop versus an open loop where you might be like pulling water from a lake or from a well and using the heat from that water. Don't really recommend or even see open loop systems anymore. Everything we see is closed loop. Next slide. All right, so that kind of dealt with heating and cooling. One of the other technologies is a means of getting efficient ventilation. Energy recovery ventilation, or an ERV, is something, I think it's required on a lot of larger buildings. And basically, this is a way to introduce fresh air into your buildings without losing heating or cooling. And so it really reduces your heating and cooling loads. And so if you're going to be building a building, you're going to want an efficient ERV. And essentially what it does is just pulls heat from the exhaust air and transfers it into the incoming air. And we're seeing these in conjunction with heat pumps. So you might have like a large ERV on a roof, and the incoming air is obviously, if it's the middle of winter, the incoming air is going to pull heat from the exhaust air, but it's never 100% efficient. So you might be bringing in 50-degree air into living spaces, and you don't necessarily want that. So what people do is, in the past, they've added a furnace that's fairly inefficient, but more and more we're seeing them use in conjunction with a heat pump to kind of condition the makeup air for this ventilation. So people don't have 50-degree air blowing onto them. So combining energy recovery with a heat pump is kind of the way to go to introduce fresh air and in a balanced and efficient manner. Next slide. I think a lot of people are struggling with electric hot water heating systems. Heat pump heating and cooling has been around for quite some time, but hot water heating is kind of where everybody is struggling a little bit. Electric resistance is what most people are familiar with in terms of electric hot water heating. Very low first cost. You can stick these units in a closet in an apartment and costs $800 or whatever from Home Depot to install it. They are not efficient whatsoever. Can be very expensive to run, but it's cheap to install and maintain. We're seeing upgrades to this, such as the integrated heat pump water heater. So the next one down is a heat pump water heater, where it's got a condenser unit on top and a storage tank below it. And this unit pulls heat from the surrounding air and puts it into the water. They're usually very efficient. They have some requirements, such as space around them. So essentially, since it's pulling heat from the air, you can't just stick it in a mechanical closet. You need, kind of like a louvered door, so air can circulate from the apartment into that closet, or you can duct it, so it's, kind of pulling air from the living room and pushing it out into, kind of underneath the stairs or somewhere where it's not going to be noticed as much. It can be noisy. It will blow cold air out of one side of it, so you got to be aware of both of those things. We have seen these both in unit, where basically they're installed in an apartment, but also as more of a centralized system. You can't stick 30 of these in a basement and expect them to work properly, because they'll cool the air too much, and it'll end up being inefficient. But we have seen a setup where they're located like in mechanical closets off of corridors, and they use the corridors for the air that they require. It's nice because it's out of the apartment. You can have short piping runs to like maybe 3 or 4 apartments around it. And it also adds free cooling and dehumidification for your corridors. So those are some of the advantages there. Technology's been around a while, so people are a little bit more comfortable with it. There are newer split systems. Sandin is one such system. The Sandin can be a little bit pricey, and it has a fairly low production rate. So it doesn't produce a lot of hot water. So what you end up doing for like a multifamily setup is you end up with a lot of storage. So basically you're just kind of making a small amount of water over an extended period of time. And the way this system works is it has like an outdoor condenser unit, like any of the other heat pump split systems, and you kind of run water piping out to it where it heats up the water, and then you pipe it inside. Expensive first cost, very efficient. I think can operate down to like -20, -30 degrees and still make hot water. But for like larger multifamily buildings, you need a lot of, you might need 8 or 9 of these systems and a lot of storage. Next slide, please. There are other technologies like the VRF system that I mentioned before, where you have like one outdoor condenser unit serving, heating and cooling multiple apartments. Those units can also be used for hot water. So the LG Hydro Kit can be used solely to make hot water, and very efficient system. Might be a little bit less efficient than the Sandon, but a little bit cheaper first cost. And made by some well-known manufacturers. There's also, I think Mitsubishi has a Q-Mark system. So there's some different system by major manufacturers that people might be a little bit more comfortable with than the Sandon, which hasn't been out as long. And then we also have solar thermal, where you're using sunlight to heat maybe a glycol mix that will then circulate through some storage tanks to heat up your water. Usually not the primary source, usually these kind of preheat water going into another hot water system. Don't really recommend these as much just because solar panels, PV panels, produce electricity at a much higher efficiency than solar thermal water panels. So, you know, we're kind of recommending that you use your rooftop for PV panels instead of kind of solar thermal water generation. Is a, you know, it's a more efficient way of doing it. And then finally, ground source heat pumps. So if we're, looking at ground loop for heating and cooling, we can also do domestic hot water where you have a water to water heat exchanger. And you can produce hot water efficiently that way. Next slide. Best practices for all these is lower your loads, your heating, cooling, hot water loads by upgrading your envelope, low flow fixtures, all the kind of building science things first, and then size your heat pumps for that. Steady state temperature, you don't need setbacks. They operate best kind of working at a low speed all the time. Make sure people are educated. Don't oversize them. Obviously solar can help offset the costs of your electricity. Electricity can be very expensive compared to gas, so look at solar PV. Electrifying your buildings can obviously make it so you can eliminate your gas meters, so you don't have a monthly meter fee and all the infrastructure that goes with gas meters. And then manage your refrigerant. Make sure installation is good, because the refrigerant that's used in any of these heat pumps is terrible for the environment if it gets released. Next slide. All right, thanks guys. I know there's a lot of information there.
All right, guys. I'll be talking about the incentives. The three incentives I'll be talking about are the New York State Clean Heat Program, the Affordable Multifamily Energy Efficiency Program, and the New Construction Housing Program by NYSERDA. You can go to the next slide. So the New York State Clean Heat Program basically incentivizes projects to install air source heat pumps, ground source heat pumps, and these two slides basically show the basic the incentive breakdown for each respective type of heat pump. For example, category 2 shows you cold climate air source heat pumps at full load heating. You get an incentive amount based on BTUs. If you go to the next slide, this shows you more custom savings or custom incentives based on BTUs of savings. Then there's other savings where you're going to have per unit breakdown. So they'll give you incentives based on the number of units that are installed. Keep in mind, this basically have the same application process, but then you'd work with a third-party verifier to make sure that all that equipment is being installed on site as it was applied for. So you can go to the next slide. So this program, the Affordable Multifamily Energy Efficiency Program, is a points-based program, and this is pretty much for moderate rehab projects. And anything 100 points and above is in the comprehensive pathway, and anything below 100 points is in the non-comprehensive pathway. The comprehensive pathway is kind of suited for larger projects, and they have you get to a certain number of points through putting in certain energy saving measures, and that's how you get that incentive amount. And if you go to the next slide. So this basically breaks down the comprehensive pathway, which we'll be talking about. I'm not going to talk so much about the non-comprehensive. So this pathway, if you get 100 points, you get upstate, you get $900 per dwelling unit. If you get 150 points, you get $1,200 per dwelling unit. Downstate, the incentives change, but we're mostly, for the sake of this presentation, going to focus on the upstate incentive dwelling unit incentives. You can go to the next slide. So this is basically the breakdown for the points. So as you can see, the more involved renovations are like, such as the insulation for the walls, insulation for the roof, gives you more, is a greater point value at 40 points. Things that are like low flow plumbing fixtures, LED, direct installs, those are about 5 points per measure. Keep in mind, all of these have like extremely specific and nuanced requirements. And, companies, third-party companies like Sustainable Comfort, we focus on making sure that those requirements are met, and that, you're definitely, we make sure that everything is squared away so that you get those points, and so you get the incentive amount on that. You can go to the next slide. So this is a sort of new construction housing program. This is exclusively for new construction, whether that be market rate or low to moderate income. And this is broken down into 4 tiers. Typically, we deal through with projects that are going from tier 2 to tier 4. As you can see, this is broken down by dwelling unit. So you get incentive amounts based on the number of dwelling units, and then it's capped per what kind of project that is, whether that's market rate or low to moderate income housing. So you can go to the next slide for additional detail. So for the sake of the presentation, I'll be talking mostly about tier 2 to tier 4. So basically, tier 2 requires that you condition your living area, your dwelling unit, with electric space conditioning or natural gas space conditioning. Electric space conditioning, you need to be certified Energy Star, and you need to meet ASHRAE. And on top of that, you need to be 20% better than the New York State Energy Conservation Construction Code of 2020s. And then for natural gas, it needs to be Energy Star certified. And then also it needs to be 25% better than the New York State Energy Code. We're seeing projects kind of going into the more all electric, which is the tier 3 and tier 4, which is on the next slide. So we're seeing projects kind of, and we're trying to sway them into getting into all electric. Tier 3 is all electric. Your HVAC, your HVAC, heating, cooling, ventilation, appliances, everything's all electric. Needs to be, again, Energy Star certified, and it also needs to be 30% better than the New York State Energy Code. Tier 4 is, again, all electric. However, this time, we want a 40% better than the Energy Code of New York State, with renewables installed, so that whether that be solar, wind, or any other renewable energy. Another thing to keep in mind, these all have very specific requirements, and the column to the right that shows the Energy Star, multifamily new construction, and ASHRAE, that's just one of the pathways. Like you could have, we have the Passive House Institute of US. So, you can go into those different pathways as well and achieve the different tiers. So it's, again, it's a very new, there's a lot of different pathways, and, I'm happy to answer any questions people may have for that. So you can go to the next slide.
Hey, I'm back. So I'll be talking about the resources now that AMPED contributes and why you should get involved with the AMP campaign. So this is a look at our website. So there's a lot of great resources, information on there. A lot of sort of what was talked about tonight. You can get some more specific information, look into specifics about your building. There's also references to a lot of other great resources. And a really great place to get started is to go to the Get Started page. And you can see that on the right here, that's what it looks like, where you can schedule a meeting with an energy advisor. And in many cases, that would be me. Or you can get started with one of the contractors through the NYSERDA programs, which I will talk more about. Next slide, please. So Heat Smart, this is the program that I run. So it's a program of the Climate Solutions Accelerator. That's the nonprofit I work for, and Heat Smart is a campaign that we run. So really what it is, it's a free and unbiased public resource for building electrification. Really more hands-on than AMPED is. AMPED is sort of like the front end, and then once you want to get in the weeds and talk about your building with an unbiased advisor, that's where Heat Smart would come in. So you can schedule a meeting with us right through the AMPED website. We're really meant to sort of hold your hand through the process, make sure you have third party helping you get the right recommendations, work with the right contractors for your needs. So what you get with us is knowledge, advice, help with the incentives, and help finding a contractor that makes sense for you. So I left my contact information on the slide, but it's also in the chat as well. And the next slide, please. So we are funded by NYSERDA. I think we've talked a little bit about NYSERDA tonight, but it's New York State Energy Research and Development Authority. They give my organization the grant to run this campaign locally. So there are other clean heating and cooling campaigns all across the state. There's this nice map here. It's also on the NYSERDA website. Yeah, wherever you are across the state, there should be a Heat Smart campaign near you. And there's no real territory or boundaries. So even if you're not technically covered by a campaign, you can reach out to any of the campaigns pretty much, and we'd be happy to help you. Next slide. So how our pipeline kind of works, just to give you an overview, is first we would have a conversation, a one-on-one conversation about your needs, what you're interested in, the situation, the life cycle of the equipment in your building, what your financial needs are, where you want to start, where you want to end up. Then we can work with you to find the right NYSERDA program for you. There's a lot of subsidized energy studies that you can get into depending on your building type, and then access some of the incentives that Simran just mentioned. We would schedule that energy study with one of those building performance professionals and review the recommendations you would ultimately receive after the study. So we can review those together. And then you make a decision one way or another, whatever you decide to do for your building, and then install it. Next slide. And so another great way to interact with us is to check us out on social media, where you can find upcoming events and get in touch with new resources as they are released. So next steps, ways to follow up after this presentation, go to the AMPED website, follow us on Facebook and LinkedIn, on our social media. Go to look at our case studies. We have financial calculators, resource on the website. Look for more events if you want to learn more, or schedule a meeting with me. So you can start with a comprehensive energy audit of your building or multiple buildings, and then we can get access to those incentives, tax credits, and more after that. So you can go to the Get Started page on the AMPED website to get started with there. Next slide. Is there a next slide? Oh, so we're going to open up for Q&A.
Thanks so much, Matt. So it looks like we do have a couple questions in the Q&A. The first one was, do you find that these incentives are enough to motivate clients to take advantage of them? Have these incentives been successful so far? So Simran, did you want to talk about your response to that?
Sure. Yeah, so we have, we do a ton of work with the new construction housing program from NYSERDA. And we have been successful in getting projects in the past and currently, getting that incentive amount. And again, especially for the tier 3 and tier 4, I think it's and we're starting to see more projects trying to strive for that. So we're definitely seeing that it's persuading developers to kind of go in that direction. And also for the New York State Clean Heat program, that program also provides like a big chunk of incentive for you for the install of clean heat technologies. Right now for the clean heat, we're still in the process of securing funding for some projects. But going back to the original question, it's definitely, we're seeing that these incentives are driving developers to pursue these avenues.
Great, thank you. Our next one is, can you tell us a little bit about the lifespan of heat pumps? Like how often do they need to be replaced?
Sure. I think heat pumps have a span kind of similar to a lot of like modern boiler systems or central systems. So you might be looking at 15 to 20 years tops. But usually once, it's similar to like hydronic systems, whatever, where you've got a lot of like the infrastructure already installed. So you just have to change out the condenser. So yeah, 15 to 20 years is what I would say.
And this one also for you, Isaiah. So you talked about a lot of technologies, some of them kind of newer than others, but are there any new technologies on the horizon that we should be looking out for?
There's a lot. One of the big things is better refrigerants, because like I mentioned, the refrigerants that we're using in these systems can have a huge impact on global warming if the systems leak. And so, all these field installed refrigerant lines, you're going to have issues no matter what. Even the best installers can have issues. So in order to deal with that, I know Mitsubishi is just introduced kind of a system where utilizes hydronic distribution. So you're looking at running water lines throughout the building, but it's got an outdoor condenser unit that basically all the refrigerant is contained in this one packaged unit, and then you kind of have a refrigerant to water heat pump. So you're massively reducing the amount of refrigerant that these systems are using. Using CO2 as a refrigerant is kind of something we're seeing as well, like the Sandin hot water heater, where you're using a very high pressure CO2 refrigerant system. And so, that's not nearly as bad as the refrigerants that we're seeing in other or the typical heat pumps. So CO2 is refrigerant, and then refrigerant to water systems. Then there's a lot of retrofit things that are coming out. The FOCA HPAC unit is one that it's kind of an all-in-one packaged heat pump system, and it only requires 2 8-inch ducts to connect to the outside. So you just mount this unit on the wall and put a little bit of duct work through the wall. It can do a room, fairly easily, and even introduce some ventilation. I think there is a Fujitsu system that's kind of a retrofit heat pump system, where it is geared towards like apartment buildings that have like through wall AC units, and the condenser unit will fit into that through wall AC sleeve and go to kind of an indoor unit. So you don't need space for all these outdoor units. and it's a great retrofit solution. So yeah, there's piles of them coming out, and we're trying to keep tabs on them and see how they're doing, and making sure that customers are comfortable with them as we recommend them.
Great, thank you. It sounds like we'll have more to talk about in the future as these things keep coming out.
Definitely.
And last question from our Q&A. I think this is for Matt. What's with the groundhog?
That's a good question. So Heat Smart has a mascot, and his name is Doug Burrows. And Doug is our mascot because he, like other burrowing animals, live underground in the winter, and that's basically how they survive the winter, because under about 5 or 6 feet of earth, it's a stable temperature all year round. Here in our climate, it's about 50 degrees Fahrenheit, but they use that to stay warm all year, and that's the same source of heat that geothermal heat pumps use to heat and cool buildings. So he's a great spokesperson for the technology. Thanks for asking.
And that's it for our Q&A. Thanks.
So our next webinar will be in March, and it will be related to electric vehicles. We're switching off every webinar between electric vehicles and beneficial electrification. So if you have a fleet, tune into that, please. And just a reminder that we're sending out a really short survey to gauge the reception of this webinar. So please take the time to fill it out if you have anything to say. And it'll also be emailed, so keep an eye out. And one last thank you all for coming. And I hope you have a great rest of your day.